In 4-7, we're going to learn our last two factoring patterns, squares and cubes. The nice thing about these, they're very easy to recognize because they only have two terms. So we started out by learning four terms. Remember the grouping in 4-5. Well, GCF can have any number of terms, two or more, but then we learned grouping, which was 4. In the last lesson, we concentrated on all the 3-term polynomials, which are either double bubble, go straight to the answer, like the first page of 4-6, or AC method with grouping, like the rest of the 4-6 packet. So these are easy to recognize because they just have two terms. We haven't learned any factoring pattern for two terms yet. So difference of squares is subtraction. That's what difference means. And the number before and after the subtraction sign is a perfect square. And this is probably our easiest factoring pattern because we know this means the signs will be different. So we do 1 plus and 1 minus, and then we just do square roots. Square root of a squared is a, so you put that in both the first slots. Square root of b squared is b, you put that in both the second slots, and you're done. The one thing you have to be careful of, though, is a sum of squares is not factorable. So let's look at two different problems. So let's first start with x squared minus 9. So this is a square and this is a square. What a square means is something times itself will give you that. X times x gives me x squared. 3 times 3 gives me 9. So if I were asked to factor it, I go, okay, the minus tells me the signs will be different. That's the only way to get a negative is by multiplying a positive times a negative. And then I just take the square roots. Square root of x squared, square root of 9. So the square root of x squared is x, so it goes in both the first slots. Square root of 9 is 3, it goes in both the second slots. So super, super, super easy. And you can easily FOIL it and check x squared, yep, minus 3x plus 3x, cancel, and then we get minus 9. So nice and easy to do. But what if this was the problem on your test? And I did put one of these on the test. Look what that says. This is a sum of squares. And right here it says the sum of two squares is not factorable. So if there isn't a GCF, you write prime. Because I cannot factor a sum of squares. I can only factor a difference of squares. So here's another one to look at. 5x times 5x is 25x squared, so that is a perfect square. It's a minus sign, so that's good. And 3y times 3y is 9y squared. So since it's a difference of squares, we know the signs are going to be different. It's the only way to get a negative. 1 plus, 1 minus. The square root of this is 5x, both the first slots. The square root of 9y squared is 3y, both the second slots. That's it. Is that like so incredibly easy after doing those big long trinomials in the last section? Wonderful. So first we have to identify if it's a difference of squares, take out a GCF if there is one, and then divide it into 2 parentheses if it is a difference of squares. So here, no GCF. So I can just jump right into factoring. Is it a difference of squares? 6x times 6x, 1 times 1. Yes, it is. Did you guys know 1 is a square, a cube, a fourth power, a fifth power? Because 1 times 1 is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 is 1. So 1 is everything. And we know that 36x squared is 6x times 6x. So once we realize that it fits a pattern, we go, okay, well, it's a minus sign, so that means the signs will always be different. So we do 1 plus, 1 minus, and then we just do the square roots. Square root of 36x squared, 6x in both the first slots. Square root of 1 is 1, in both the second slots. Okay, let's do one more and then you guys can try a couple. How about that? So 2 is a difference. That's the first thing you check. Then you say, is 1/4 y squared? So what's the square root of 1? 1. What's the square root of 4? 2. What's the square root of y squared? Y. So the square root of this is 1/2 y. What's the square root of 9? 3. What's the square root of 25? 5. So the square root of this is 3/5. So it does fit in the pattern. They're both squares and it's a minus, so I do my one of each because this tells me they'll be different. And I do square roots, and like I said with fractions, just do the square root of each one. Square root of 1 is 1, square root of 4 is 2, square root of y squared is y. So 1/2 y goes in both the first slots, and then square root of 9 is 3, square root of 25 is 5, so plus 3/5 minus 3/5. And like I said, they can all be checked with foiling, but as long as you're doing the square roots and get your signs, one of each, it's pretty hard to miss these. Okay, so why don't you turn off the video and try 3 and 4. 4B is a little bit hard, so let's do that together. I actually put that one on the test, but try 3 and 4 now on your own. And then come back and check them with me, okay? Okay, so I look at 3 and I go difference of squares. That's a square. This is a square. Even exponents are always squares, by the way. This is a square, 15 times 15. This is, but here's the problem. So what should I write? This is not a difference of squares. So what do we write when it's a plus sign? Prime. So I hope you didn't take all the time to do that one because it can't be done. And there's also not a GCF. The only thing that goes into 49 is 7, and it doesn't go into that. So we just write prime. And you might want to show why. So when you look back at this, you'll know it has to be a minus sign. That's why it's called a difference of squares. Okay, let's see how you did here. Even exponents, so those are squares. And it says right here, any even power is a square. So as long as it's divisible by 2, it's a square for the powers. And 4 is a square, right? 2 times 2. So, and it's a minus, so that means it can be factored. So we have to do one of each sign always, because the only way to get a subtraction sign is with a positive times a negative. So we do the square root of this, and you have to square root each part. So when you square root an exponent, you cut it in half. So this would be m squared n squared. So that's what goes in both the first slots. And then we take the square root of the last term, 2, that goes in both the second slots. Love it. Nice and easy. So much easier than AC method, right? Okay, B I did put on the test, and this is actually number 1 on your final exam too. And I think I put a regular square one on too, so let's do number 1 too. It's actually a 2-step problem, which you'll see on the next page, but that's still a good one to study. Actually, I think it's more like this one, the one I put on the test. So there's one like this, one like this, one like that. So we have 3. So the example, number 1 and 4B should be the ones you have highlighted, because I kind of did that fast and didn't tell you, right? So the example, I think this is the second problem on the second page of the paper pencil test. So that means it's like number 7 or 8 or something. And then 1 is like another one, and then 4, On the paper pencil test, it's the top of the 3rd page. I don't know where it's going to be on the Alex test. Okay, so is it a difference of squares? That's the first question. Well, it's a difference, and the exponents are even, so it is a difference of squares. So I go, okay, has to be different signs in order to get the minus. So 1 plus, 1 minus, and now I take square roots. And like I said, when you take the square root of exponents, you just cut them in half. So x squared goes in both the first slots, y squared goes in both the second slots. And so on the paper pencil test, many people stop here and they get half credit. So can anybody tell me why I don't stop here? I wish you guys could tell me. I wish I could hear you. Difference of squares. Remember how I told you there's going to be 8 problems on your test that factor twice? Well, this is one of them. We know this can't. Remember, sum of squares is prime, so it can't factor again, so it comes down as is. But this one is a difference of squares, so guess what? It goes again. So x plus y, x minus y, because this says the signs will be different, and then you do the square roots. Cut the exponents in half, so x to the first, cut it in half, y to the first, y to the first. So all of this will be your answer. So not only is this on your upcoming test, it's number 1 on the final exam, or at least a paper pencil. I don't know about the LX one, but probably close to that. Okay. So these are pretty fun, right? Fun and easy. Very highly missed on the test. I think it's because it's 1 page and it goes away and students don't go back and study it. So if you have highlights, maybe you'll remember to go back and study it before the test. Okay. And there is 1 prime. We forgot to highlight that too, huh? So that's a lot of test questions on 1 page, isn't it? But this is a very common factoring pattern. Right up second place to the trinomials. Trinomials are the most common. Next are the difference of squares. Okay, so 4 highlighted there. The example, the prime, and I could put this one, but the prime's not that ugly. It's more like this, so that's a better one. And then 4b, which factors twice, and you have to factor it twice to get full credit. Okay, let's look at the next page. So I also put one of these on the test. I think the example would be a good one to study. There's probably other ones here too, maybe 6. We could highlight the example and 6 on this page. So this one combines methods. So it's one of those 8 that I told you is going to factor twice. So it combines method. First thing you go, well, there's nothing common to everything, but wait a minute, I count 4 terms. Whenever it's 4 terms, remember it's grouping. So you group the first 2 and you group the last 2. So the GCF for the first 2 is x. I take that out. When I take an x out of there, I'm left with y squared. Minus, when I take an x out of there, I'm left with 9. And then remember, I always bring the sign down. These 2 have nothing in common, so I take out a 1. When you divide by 1, you get the same thing back. And this is your happy dance time. Woohoo! Parentheses match, so you pull that out as your new GCF. Remember, on grouping, we do GCF 3 times. 1, 2, 3. Then we cross it out, and whatever's left goes in the second parenthesis. And so, like I said, a lot of students just want to factor once and walk away. They don't look at the problem, but there's still something to do. It's a difference of squares. So it can factor again. So 1 plus